If you have any questions, just make sure you keep those questions. This is your chance. This is your chance to ask any questions that you have about working at NASA, working at Kennedy Space Center, or my particular career. And you see there that my title is Failure is Not an Option, and that if you've ever seen Apollo 13, you might get that reference. That's something that was said when we had the Apollo lunar missions that were going to the moon, and there was an anomaly during a flight, and they had to find creative ways to get the astronauts back home. So mission control said failure is not an option. Well, it's funny for me because my line of work is failure analysis. And that means that I work in a lab mostly. Now I'm managing people that work in a lab, but started out my career working in a lab looking at failures. So if you've ever had anything fail, any kind of, I don't know, a cell phone, anything in your parents' cars or your cars, anything at home, we would do look at that and let you know why it failed and make sure it didn't happen again. Now we're doing it with rocket parts, but it's the same concept. If you've ever looked at something that's failed down the middle, cracked, whatever, that's what we would do. So it's a pleasure to be here. I'm going to give you a background about myself, my life, how I got to where I am, and really excited because I do have two sons. One is at hopefully future Hornet, as Father Anthony likes to say. So we are kind of connected. He goes to Good Shepherd Catholic School. He's only in second grade, so he still has a long time until he makes it to Bishop Moore. But we are very involved in our church. So I am Catholic, and we go to St. Isaac Jogues Church, and we are at Bishop Moore every year for Laps of Life. So and then the soccer games that, I don't know if you're ever there on a Sunday and there's a lot of little kids playing soccer. That'll be my son this coming Sunday. So I have a nice connection with Bishop Moore. And Father Anthony baptized my youngest son, who's only a couple of years old. So lots of connections there. All right, I do have a video. I'm not going to play it because I don't know if it'll transfer. So it'll be available, and I can provide the link. I have a video that was created at NASA. They had this whole initiative of women at NASA and showing people's career, and it gives you a really good background about me. But I'm going to talk it, so you don't have to watch the video now. I don't want to break anything while we're doing our Zoom, so you can see that later. But my background is I was born in Colombia, South America. That picture there is a little old me when I was in probably first or second grade, and that's how my parents' house in Colombia. We lived there until I was in the third grade. And then we moved to the United States, to Florida. I grew up in the second half of my life, I guess, in South Florida, and never imagined that I would be where I am right now at all. No concept of that. When we first moved to the United States, I didn't even speak English. I was first day of classes, didn't understand much, maybe 5 words of what people were saying to me. So long way to go. And even though you may not be able to associate with my experience, but what I would say is, like, don't cut yourself short, and you don't know where life is going to lead you. I would say I'm here because of hard work and just being open to the opportunities around me. So one of the things when I was little, I loved puzzles. So if you like putting together jigsaw puzzles, you have an engineering mind. So right away, I said I look at why things fail. So that's problem solving. I like to put puzzles together. That's problem solving. So that's kind of that engineering mind of how do things work? How do things fail? How do you put things together? So I always liked that since that age. Puzzles were my thing. So I do have a picture here of myself in Colombia going back now as an adult. And that's just kind of it's really colorful, really pretty country. There's a lot of issues there. So it was getting very dangerous, and that's why we moved to the US. And so this is me now working at NASA much later. But I like this picture because if you've never been to Kennedy Space Center, hopefully you'll have. You live so close. You would see that iconic building, our vehicle assembly building. And then what I'm standing next to, you see I'm at the front. Hopefully you can see that well. I'm at the front of the countdown clock. And that countdown clock is what was used during a lot of missions that have gone to space. And they were about to tear it down because this was an old type of countdown clock. Now we have a nice big digital multicolored display. So I make sure to always go out and take pictures at anything at Kennedy Space Center that's very historic. And so I like the, the showing in the background, we have the big vehicle assembly building. That's where we stack rockets together. And then in the middle of this picture, There you'll see a tower. That is our new mobile launcher that's going to be used for the new rocket that I'm going to talk about in a little bit. And then you have this really old countdown clock. So pretty cool to see that all together. And never imagined that I would end up here. So a little bit about what I did when I was in high school. I went into a math, science, and engineering program. I didn't know too much about engineering, honestly. I didn't know much more than maybe we had a couple family friends who were engineers, or someone came and talked to school. And it wasn't until that one teacher asked me while I was in high school, I was a physics teacher, what do you think you're going to do study in college? And I said, well, maybe an accountant, maybe a doctor, maybe I had maybe 10 different things that I had no idea. I knew that I wanted to go into something maybe numbers related. I was always very good at math. That's why I went into this high school special magnet high school program, but I didn't really know exactly what I wanted to do. And he said, you'd be a good engineer. You should consider doing it. I don't know if he hadn't said that to me, if I would have gone into engineering or not. I might have, but it's always that one. So right away, I'm going to give you that encouragement that if you haven't looked at engineering, look to see if that is something that you think that you could do. During high school, we also had these summer programs, and we went to biomedical engineering summer, like it was a 2-week program at the University of Miami. We stayed there for 2 weeks. A bunch of high school kids getting in all kinds of trouble, but we learned a lot about what it takes to be a biomedical engineer. And that was really, really interesting to me. The reason being that I had said medicine maybe is something I wanted to do. Well, now I could kind of do that problem solving in the medical field. And I thought, oh, that sounds like a great. So by the way, I'm not talking NASA yet. NASA was not even in my mind. When I went on to the University of Florida, you'll recognize that. Hopefully we have some Gator fans, and if not, that's okay. I love the Gators, by the way, but nothing against other schools, but I love the Gators. They didn't have a biomedical program, and I knew that that's something I wanted to do. Very smart thing that you can do once you go to college is they have some courses that are introductory. So they had an introduction to engineering, and during that course, you could go and look at all the different disciplines of engineering. Engineering is not just one thing. It's not just one career. No engineering is the same. And one thing that I really like was materials engineering. Materials engineering is very closely related to mechanical engineering. Most people haven't heard of materials engineering, but think about all the materials that you use throughout the day. Think about all the materials if you're sitting at home in front of a computer. Think about all the materials it takes just to have this picture in your screen. If you're in the room at school, think about everything around you is made up of materials. Well, somebody had to really think about what material would be able to do the functions of whatever it is you're looking at. So biomedical engineering, very closely related to materials, because if you're going to do something like a pacemaker, something that's going to go in the body, you need to have it be very compatible with what it's going in. So in that case, the body. You can't have something, for example, a hip implant, or if anybody has had any kind of surgery where you had to implant something into your body, you don't want to have something that's going to start rusting, and you don't want to have something that's going to dissolve, not necessarily, or maybe you do, right? There's things that you can think about in order to have that compatibility with your body. So anyway, that's where the materials came in. And then I decided I wanted to go get a master's. I went to Penn State. So if you recognize that symbol, and you might be a Big Ten fan, that's Penn State. Also love Penn State, by the way. And I got my master's in material science and engineering. Along the way, as I was at both at UF and at Penn State, I had a lot of internships. And this is something that you'll find as you start thinking about what career you want to do. This is a great thing because you go and work a summer or any semester, really, once you're in college. You can go and work at different companies and get a good experience of what the company's like. You get a good experience of whether you like living there or not. Some of the places that I did internships are at the top right, that's Florida Power and Light. I worked in one of their lab buildings, and we did get to go out to power plants and things like that. I did one summer like that in West Palm Beach. The left picture is I spent 4 different summers, 4 different terms going and interning for ExxonMobil. So that is different fields. So it went from utilities and electrical to gas, natural gas, and they do electrical energy or renewable energies and things like that. I worked in a refinery. I was like in the here's what it takes for you to have a car to work, right? You have to have gas. And I was working there in the middle of all of the big machinery. I loved it too. And I was in Baton Rouge for 2 summers, and I was in Fairfax, Virginia, which is just outside of Washington, D.C. And then the picture on the bottom right is my Penn State picture. I always joke because since I grew up in South America, so no snow there, and then Florida, no snow here. And I guess I was a little sheltered because we never went anywhere in the winter where we would see snow. It was all just a thrill to me to go to a school where there was snow. And so that's my Penn State picture. Kind of funny looking at it now, but I wanted to get that experience of what it's like living in a different environment. So I was always just open. Remember, I mentioned that, open to opportunity. And that's what I did with school. So how did I get to Kennedy Space Center? Up to this point, you saw my internships weren't NASA related either. So not to say that I didn't appreciate space and appreciate, because there's some people who say NASA was my dream. Since I was little, I knew all about the space shuttle, or I grew up watching the lunar missions, Apollo, or whatever it is. Some people are like, that is what I'm going to do. Maybe we have someone in the audience who's like that. I was not, but I was always intrigued by it. We went to space camp when I was in middle school. So I did come out to Kennedy Space Center a number of times. But it was this far off dream. It was one of these, like, I didn't even know how you got to work at NASA. I didn't even think about it. Well, while I was at Penn State, my last year, we have these things called career fairs. And the recruiters, right now they're a lot virtual, obviously, but we'll get back to doing the in-person career fairs. I think most schools are back to doing them now, most colleges, where you see all of the companies in the big arena of the college mostly, and they'll have booths set up, attracting everybody. That's how I got some of my other internships. And while I was at Penn State, I had offers from oil companies, but I wasn't sure if that's what I wanted to do. And I saw NASA and I thought, well, NASA would be awesome. That would be great. I got in the line, I had my resume. So you had, printed resume in hand. I go up to the recruiter and I introduce myself, and you should always be ready to do this. Have this little, we call them elevator pitch, or like this little 1 minute description of what you do or what you're there for. So I gave my little 1 minute saying, hi, my name is Clara. Oh, go back. My name is Clara. I am a materials engineer. I'm very interested in NASA. He had on his name tag, it said Kennedy Space Center. I said, I see you're from Kennedy Space Center. I would love to go there because I grew up in the area. I have family in Florida. That's where we launch everything. And I'm interested in failure analysis. At that point, I had already learned what that was. And the recruiter says to me, oh, I am the manager of a failure analysis group at Kennedy Space Center. I mean, completely random, but being open to that. And since I know that for me, it's all faith-filled. For me, this was where I was meant to go. This is in place for a reason. I did get the job offer, right place, right time. It was my path, right? And so that's how I ended up at Kennedy Space Center. So just to give you some idea of what I've done throughout my career, I started out in 2005, and I did a lot of hands-on lab work or going out. So really cool pictures. On the top left is a picture. I'm inside of one of the modules that are now in space at the International Space Station. And we were doing inspections to make sure everything was good, and actually to make sure everything was clean, something you don't think about, but you'll see various pictures where I'm wearing a full outfit that we call bunny suits, like a rabbit bunny. I know we have some funny terms for things, but the reason is because think about what happens if you have a very dirty module or spacecraft or whatever's going into space. What happens to all of that dirt, debris, contamination as you go up in space and you have no gravity? So all of a sudden, all of those things are going to start floating, and they can get into astronauts' eyes, really hurt them. So we have to make sure everything's nice and clean. I have pictures out at the launch pad. I would go out to the launch pad a lot. Bottom right picture is with another astronaut that's a materials engineer, Danny Olivas. We did an investigation together, and some of the pictures in the lab as well. During that time, so I started in 2005, shuttle program. very important. The shuttle was a reusable vehicle. It launched vertical and then landed as a glider. And, you know, it looks like the orbiter piece looks like a plane. It could fit a crew of up to 7 people. And it had a big payload bay, which is where we would put anything that's going up into space. A satellite or one of the pieces of space station could fit in the back of the shuttle. But it was also very old. There were actually 3 different, at the end of the program, 3 different orbiters that plane part. And some of them were about 15 or so, no, about 20 years old. And then some were about 30 years old. And there are a lot of parts to that. So they were getting older. We were looking to transition into doing other kind of work. And so I helped to do all of the closeout. So all of the building of the space station. And I'm going to show you pictures of all of this in a little bit, as well as closing out the shuttle program. Some really cool views there. You can see some of the experiences. And then after shuttle, we were still, a lot of people said, well, did NASA close during that time? Because all you would hear in the news is the shuttle program's ending. Well, the shuttle is only one of many programs we have at NASA, but we also continue to do, so the International Space Station was being built with the shuttle all this time. And now we had a full functioning space station. So as a materials engineer, some of the things I did, for example, there's a picture in the middle that shows a flower. I helped to work on a payload or an experiment that went up to space station and would grow. It's still up there. It's called Veggie. There's 2 of them actually, Veggie and Advanced Plant Habitat. How do you grow vegetables in space? How do you grow flowers in space? It sounds like something simple, but think about what it takes to water a plant on Earth, or even what it takes for a plant to grow. You need soil. Well, if you have soil and you're in microgravity or, you know, weightless, basically in an environment where nothing's holding that soil together, you don't want that to go everywhere. I already mentioned how that is very dangerous for astronauts. It's also dangerous for all the systems. And so you need to find a way to contain it. Then you'd also need water. Well, how do you get water? In space, water doesn't flow the same as Earth. So how do you get water to the roots of that plant so it can grow? And then light. We need also sunlight in order for a plant to grow. Well, we don't necessarily have that. As the space station is orbiting around the Earth, it's only getting sun every so often. And so what we use is artificial lights. And the pink glow that you see like in the middle picture there, where I'm with one of my coworkers, that's LEDs that are made specifically. So they use red, green, and blue LEDs to ensure that the plant grows optimally. And there's been all kinds of studies on what that combination is. So those are some of the things, like we were working on all of these experiments. And we were also getting Kennedy Space Center prepared for 2 major programs. One is called Commercial Crew, which you've probably heard a lot about lately, SpaceX launching astronauts. That's our Commercial Crew program. And then the other one's called Artemis. This is a big rocket that we are in the final stages of getting built. So one of the things that, if you've never thought about space too much, is that we've been to the moon back in the 1960s, 70s. We haven't been back since then. Everything else we've done has been around what's called low Earth orbit. So the space station is 250 miles from Earth's surface. Think about what's 250 miles from where you're sitting right now. So maybe that gets us to Georgia, let's say. That's not very far. The moon is 250,000 miles away. And then if we're talking about going to Mars, then that's over 1 million miles. You know, that's much, much more difficult than just going 250 miles. And so all of the things that we need to take with us to space, all of a sudden we need this much bigger rocket to get us to further destinations.
Clara,
yes.
Just real quick, for some reason, you just became a lot softer. And we wonder if it perhaps was something that you did on your end, or?
Can you, oh, no, it looks the same on my end.
Oh, it does. It does. Okay. Lindsay.
You need me to talk? Can people on Zoom hear me okay? Is it like a room thing? Or
Up to my audio.
If you're on Zoom, give me a thumbs up if you can hear me okay. Okay, thank you. So we do get the okay on Zoom. It might be in the room if you can still hear me.
Yep, you're good.
Thank you.
We're good over here too.
Can I keep going? Okay. All right, so I'll keep going. So one of the things we also were working on is getting those commercial crew vehicles. There was a big shift in philosophy of going from our shuttle program, which was mostly government run, but we had a lot of contractor support. So we had a lot of other people working on that shuttle program, but it was mostly NASA making a lot of the calls on what we were going to do. With the commercial crew program, now we were asking different companies, Boeing and SpaceX in particular, to create their own, use their own rocket and use their own capsule or spacecraft. And we, NASA, just certified that it's meeting all of our requirements. And so during that time, I shifted from doing most lab work into doing certification. So that means for the thousands and thousands of materials that are being used by Boeing, for example, in their capsule, I had to make sure that they were good to go into space. And there's a lot of things you have to consider with that. I'll give you one example is flammability. When you're in space, you don't have any oxygen. So we have anything that's in space is it's called a closed loop system, but you have to feed air into that and pressurize it and give the environment for the astronauts to be able to live there. In order to do that, we have to have a high oxygen environment. We can't get so low in oxygen that the astronauts would pass out. And the only way to ensure that is we always are pumping a lot more oxygen than nitrogen and other. So our gases in space station, everything's in that high oxygen environment. And in high oxygen environments, you have materials that normally on Earth would be okay. They would all of a sudden be more flammable. So they could catch fire a whole lot easier. And we have to make sure that anything that's sent into space won't be an added hazard to the astronauts, to the crew, or to the space station. So those are the kinds of things we are looking at. I do like to point out here, I have a lot of pictures with other people. That's because in engineering, you're always working with other people. And then I have a picture of my family because my family is so important to me. So I had to include that. That's an old picture. That's my second grader who was, I think, 2 or 3 at the time, maybe 3 at the time. And so I need an updated picture with NASA in the background with my family. And then as I moved on, I took on more leadership roles, became a manager. So that's what we call a branch chief. And then right now I'm currently actually acting as a supervisor to supervisor. So I am overseeing a team of about 7 to 10 supervisors. And the whole group is about 120 people between engineers, technicians, things like that. So I moved up, and one of the things that to me is important is to make sure, we always make sure the technical work is done well, but as I moved a little bit further away from being in the lab, I also have to make sure that the people doing the work are really taken care of, and they can do the best work that they can. So I like to put pictures here of our team, and these are just a few of, we have a very big team. Okay, I'm shifting over a little bit to talk about engineering at Kennedy Space Center. So I've already touched upon a few of these things, but we have this long history of exploration, and not just on Earth, but in other planets too. So as this cycles through, you'll see different missions. So crewed mission, when you hear me say crewed missions, that means with a human on board, have only been to the moon back in the Apollo days, and then now on space station and the space shuttle missions. We've never been to Mars, but we've sent robots to Mars. And Mars is the only planet where we've sent something to land. So the robots that have landed on Mars, and you've probably heard recently about our different rovers and the helicopter, right? Ingenuity and Perseverance is a rover. And then other planets, we've sent things to orbit around or fly by. So we've had missions that go to Saturn and missions that go to all the way to Pluto, past Pluto. Those have been some of the more recent exciting ones. And we have to make sure all the engineering is right in order to get us there. It takes a big team. I should also mention, let me see, again, we've been doing this for 60 years. I should also mention that if you think, well, maybe engineering is not for me, then there's a lot more that's being done at Kennedy Space Center and at NASA in general. NASA has 12 centers, and we need all kinds of people, right? All walks of life. And I could talk about that a lot, but I'll focus on engineering, but there's just a lot of different careers that at NASA. I want to point out a few recent things for what the work we've been doing. Well, obviously, since the start of the pandemic, we've been on mandatory telework. And you might be asking, how do you launch rockets when you're working from home? We probably have had about 20% of our workforce at Kennedy Space Center and the other 80% working from home. For me, I'm working mostly from home. I do go on site maybe once a month, sometimes more. I do still do some lab work a little bit, or I actually do an analysis of lab work, which means somebody else might be on the microscope or doing the test, and then I take that information and we talk about it, and then I create a report. So I'm still doing that kind of work a little bit. Between all of last year with the start of the pandemic back March of 2020, we've had several big highlights for NASA, really. We've had SpaceX launch that first crewed flight after shuttle. It had been a while. It had been 9 years since the last shuttle mission. And so we were able to certify and make sure everything was safe. And since then, we've had several of them. We've had test 1 and 2 more common flights to the space station. And I talked about Perseverance landing on Mars. Then we have the big rocket. I keep calling it the big rocket. It's called Space Launch System, SLS. And you see on the bottom picture, it shows that orange tank, kind of similar to the shuttle tank, but a lot bigger. And that is on its way to our big iconic vehicle assembly building. So we started to stack that rocket. I'll show some pictures of that as well. And then there's so much more that we've been doing. Let's talk a little bit about the International Space Station. What you see in that animation really fast, you can't really read it, just to show you the jigsaw puzzle, and I talked about that, of what it takes to build a space station. All of these different parts had to be sent up on a different shuttle mission or a Russian mission, and then they had to be put together, but they couldn't just start putting together piece A and piece B because they needed different, energy. They needed all the different things that it takes to get them pressurized and put together in such a way. So you'll see like solar panels moving from one side to another, and it took a long time. So from 1998 all the way to 2010, 2011, international cooperation, a lot of different people worked on this. That's the international cooperation. You can see the flags along the bottom, and then some of the locations of where we had different countries, give different parts of space station. That's a schematic of what the International Space Station looks like. Anything that looks like, we call them tuna cans, but anything that looks like a can, that's that pressurized volume. If you remember, I had a picture where I was doing an inspection. It was one of the first pictures I showed where I'm doing an inspection, and I said it was a module from the International Space Station. It was one of those. And then size-wise, it is as big as a football field, including the end zone. So about 135 yards long if you go from one end of the solar arrays to the other. And then here's pictures of some of the things that I've been involved with, which I told you about the plant growth. How do you grow plants in space? I help with the materials for that. I've done a number of other things, but I think this is one of the cooler ones because unless you stop to think about what it takes to grow something in space, you don't realize it. A few more cool pictures of the International Space Station. I do like to show the one with the water bubble, because that's the reason why it's so difficult to water plants in space is water tension in that microgravity environment. Water just wants to cling to itself almost, and it doesn't necessarily flow here. Mostly it would be flowed down, or you'd have to purposely design things so that the water goes in the direction you want it to. And then you see the SpaceX Dragon docked onto, so that capsule, the bottom left picture, that's where the astronauts would go, and that docks to space station. And then that's when they're able to go inside a space station. You can't just open the door, by the way. You can't just go knock on the door. You have to get them to the same pressure in order to be able to then open from the inside. Never want to go to outside of a capsule. It takes a lot to go outside a space station to do a spacewalk. And then here's a little bit more about the commercial crew program. So I just showed you that capsule docked to space station, and this is what we've been working on for a long time, is to get all of these rockets or launch vehicles and the spacecraft ready for our astronauts to go to space. The previous one was all SpaceX. Boeing is also doing the same thing. Little bit different design in terms of what their capsule looks like, but same idea of making sure it's all ready to go so that our astronauts can make it to space station. And by the way, once they're in space station, they're doing a lot of different science experiments that help us to do things better on Earth. And that's the whole point of the space station. We're doing all of these experiments in medicine and in materials and in all kinds of manufacturing processes that then will tell us how we can improve processes here on Earth. Okay, so if you were to look at Kennedy Space Center looking down, one of the things you would see is we have multiple launch pads. So if we're looking down at the coast, if you've been to Cocoa Beach, is just south of what I'm showing here if you're looking from space. And we have a couple of different launch pads that were the main launch pads that were used for Apollo, so the lunar missions, as well as for the space shuttle. And then we have that vehicle assembly building is right here shown where it says Launch Control Center. That's where that is. And then my office compared to this is south of here. That's what the launch pads look like. I wanted to give you a little history lesson of the launch pads back during the Apollo days. And back then, the rockets, the lunar rockets would roll out to the launch pad with that red structure that's right in the middle. And then would take off from there, would launch from there. Then during Space Shuttle, they added all of these other pieces because now we had that plane looking part, the orbiter, and it needed to be accessed from different locations. So they had what was called like a fixed structure out at the launch pad. And then here's a few more pictures of shuttle. This one's hard to see, but it's the same launch pad. They just changed a lot of the way that it's built in order to access different things of the space shuttle. And there you can see the shuttle really well on its way out to the launch pad. And then now that same launch pad, one of the two, is being used strictly by SpaceX. And they have now all of the access points for their launch vehicle, for their rocket. So it was remade completely for SpaceX. They have a lease on it for the next, I think, 30 years. So they'll be there for a long time. We have other facilities that were used strictly for shuttle. So here's an example of one. This was called our orbiter processing facility. So that's just the plane part going in, and that's when we have to replace things and all of that. Now Boeing is using it for their capsule, which is called the Starliner. And that's me in front of it. I did a lot of work in there. And that's how all of these are publicly available images, but this is how they were putting their spacecraft together. And then the whole idea is to be able to send more astronauts to space station and be able to launch from here, from Kennedy Space Center. Same astronauts as we had before, some newer ones, and all going to do all these cool missions that we have. And then the new big rocket called the Space Launch System. It's part of the Artemis program. You're going to see this rocket, the picture on the right is not real yet. That's just a digital reconstruction of what it's going to look like once it's out at the launch pad. But we are almost there. You're going to hear about this rocket launching in the next 6 months or so. So vehicle assembly building, that's where we would get all these rockets ready to go out to the launch pad. Here's what it looked like during that lunar program back in the 1960s. And you can see here, I mentioned about the rocket and the tower going together towards the launch pad. Whereas in shuttle, it was just the rocket going to the launch pad. So the vehicle assembly building, 555 feet tall. Give you an idea of what that means is if you were up close to that flag, you could drive, it's as big as a highway lane. So you could basically drive a car on the flag. And the stars are bigger than a person. So it looks tiny, but it's a huge building. Actually, you can see how big it is based on the cars at the bottom. You can see all the cars there. Nothing like going up there and just looking up. It's really cool. There it is during shuttle. One of the things you might notice is how little the shuttle looks compared to how huge that building is. The shuttle was a lot smaller than the lunar rockets. And then here's an actual picture of our moon rocket that's coming up the big SLS. So that is they're putting it in position, getting everything we need in order for it to launch. And again, a reconstruction, but these will become real pictures within the next 6 months or so. We'll be ready to launch. The building I work in has a lot of history too, so I didn't want to leave that one out. It's called the Operations and Checkout Building. It was built for the astronauts during the Apollo missions. So and then in the back, they would do all kinds of testing. So these are the smaller capsules that were used back in the 1960s and 70s. If you recognize that, Neil Armstrong, if you don't recognize, his name tag is right there. But first man on the moon. And they have the crew quarters in my building. So even though we have labs and we have processing areas, we also have a whole area where the astronauts, when they come to Kennedy Space Center, that's where they stay. And we call them the crew quarters. All the way back from the 1960s through the shuttle program, and this is a shuttle crew. Shuttle could hold a lot of people compared to some of these other smaller capsules. And then that's where the new astronauts are coming out now for SpaceX launches and for Boeing launches. And then here's the capsule that we're working for the big rocket. It's called Orion. So that one is this is an old picture. This is a long time ago. That one is ready to go now. Okay, so that is what I had prepared. I did want to give a little bit of advice and then I'll open it up for questions. I talked at the beginning about internships. So internships, as you start looking at going to college and what you're going to study, you should look into working in the field that you want to study. So in engineering, usually they're paid internships and you get to see what that company is like. You get to see what the work is like and you get to see whether you feel like you fit in there or not. And that's called the company culture. You get to see all of that. And then the company gets to kind of interview you along the way as well. So it works both ways. Take advantage of hands-on learning opportunities, especially as you're in high school. You have so many opportunities, but you have robotics clubs or anything where you can get your hands, even if you think this is nothing I could ever do, just go in there and learn it. Don't sell yourself short, just go and take advantage of it. I mentioned this also, be comfortable about talking about your work. If you were to pull that 5 or 6 year old girl that I showed at the beginning and say I'd be presenting in front of, sometimes it's hundreds of people, thousands of people, I wouldn't believe it because by nature I am very shy, by the way. And I had to kick myself out of that. I had to learn to be able to talk in front of audiences and give presentations, and little bit each time gets better and better and better. Now to me, it's not a big deal to give presentations, but man, when I was in school, do not put me in front of anybody. I don't want to talk. Had to do a lot of practicing. Oh, and this one's really, really important. You probably already work in groups and in teams, and you will always have to do this, no matter what. Well, maybe there's professions out there where you don't have to. In engineering, you do. A lot of different careers you do. And sometimes it's difficult. Sometimes you have a great team, but you have to learn about how you are contributing to that team and how you work well with others. And I also like to say, I'm very, very hard worker, but I encourage people to also make sure that you have other interests as well, and make sure you're taking care of yourself. Mind, body, spirit, emotional well-being, very important, very important. And be passionate and dream big. That is all I had. And I know, my favorite picture from the Hubble Space Telescope is called the Rows of Galaxies. And so this picture was taken, it's actually 2 galaxies interacting with each other, but it looks like a rose. So this is one of my favorite Hubble pictures. There's some really, really cool Hubble Space Telescope pictures. And leave you with the NASA meatball, as we call it, and the view from space station, seeing the aurora borealis from space, pretty amazing things. And then I like, I'm open for questions. I don't know how we're going to do it, but would love to take some questions if anybody has anything.
Hi, my name's Lindsay. I'm the student moderator for this series, and I'd like to thank you for taking the time to give your presentation and your incredible insight. I know I enjoyed it, and I'm sure my peers did too. So yeah, we'll open up the floor for questions right now. Zoom kids, you can chat, any of your questions. And then kids here, if you have any questions, you can raise your hand and come on down and ask. But in the meantime, I actually had a question for you.
Sure thing.
So you had mentioned that you were initially unsure of which career path to take. So my question for you is, what swayed you to material engineering?
I had to do a lot of, I think it was incremental. So I think it was a little bit at a time. First, it was, could I be an engineer? I started looking at what engineering meant, and I thought, yeah, I could do that. I'm a problem solver. I could do that. And then we did that biomedical engineering. And that swayed me towards doing something that might be medical related. But then when I got to college, when they didn't have that available, that's when I started learning a little bit more and more about materials. And it was when I did my first internship where I was looking, it sounds funny, but I was looking at parts that had broken and trying to figure out that, just like really my mind is like, wow, this is so cool. You're trying to figure out why something failed. And so it was this little like step by step by step, just being open to, well, maybe this could be a career. You know, I didn't have my mind fully set on something. I was just open to learn about everything.
Thank you. Does anybody have a question they'd like to ask? So we actually have a few more questions. One, do you foresee another trip to the moon anytime soon?
Yeah, it's very challenging. So you would think we already went once, why can't we go again? A lot of that information was just lost over time. And a lot of the funding is not there because it takes a lot of money to do that. And so even like the NASA budget back in the Apollo days when we went to the moon was something like, it was like 2.5%. I don't want to say the wrong thing, but it was a huge percentage of the whole government budget. And we are much, much lower than that. We're like less than 0.5% of all of the government budget. So it takes some time. But our plan is once we get this experimental rocket, the big rocket going, yes, there's going to be people on that rocket. And so we have two missions. We have an experimental mission, and then we have one with astronauts that will go all the way to the moon. And then we have systems that are being worked on landing on the moon to do work on the moon, not just to go for a week. We're looking at going and staying there longer and looking at what it takes to live somewhere else long-term that's further from Earth than the space station. So eventually we could go on to other places like Mars. So the answer is yes, definitely. It's just a matter of time.
Okay, great. And a quick follow-up question, if you have time, do you foresee another trip or a trip at all human to Mars?
Yeah, I do. I don't know if it'll be while I'm at NASA, because again, the challenge is to just get us to space station, then to get us to the moon, and then to get us to Mars. All the things like food and drink and air, we have to think about so much. So I think it'll happen, but it may not be while I'm at NASA. It might be while you guys are at NASA, but not while I'm at NASA.
Okay, thank you. And looking at the time, we're looking like we need to wrap up soon, but thank you so much for coming and sharing your insight with us. I know I thoroughly enjoyed it, and judging upon my peers' faces, I think they have too.
It's no problem at all. If there are any other questions later on, I do give these talks all the time, and also willing to take questions by email. I know one of your teachers has my email address, Ms. Grady, so she can always connect us.
Great. Thank you so much, and have a great day.
Thank you, Clara.
All right, no problem.
Thank you.
Bye-bye.